So once we are done with data collection, the next step comes is data analysis, and it depends whether the data analysis is complex and it's simple, which is basically becomes the deciding point of whether we have to use PLS SEM, whether we have to use CB-SEM, SPSS, and whether we can analyze it in Excel. For example, if there is mean median mode, we have to find mean median mode or descriptive analysis, then simple SPSS and Excel can also do that. But in case we have to do there is multiple regression factor analysis, there is path analysis involved, we have to find out that, then I think SEM, structural equation modeling, is something that comes into the picture. A very good evening everyone, my name is Rahul Negi and you're watching me on the Scholars Guide. So this basically is the topic, that is PLSM versus CB-SEM, and it is one of the most important topics for the people who are doing PhD, for people who are going for the data collection, going for the data analysis. So be attentive throughout the class. Introduction. Whenever a researcher wants to study multiple variables simultaneously, means they want to study multiple variables, but at the same time, especially latent variable are basically the backend variable who uh, then bifurcate themselves into independent variable, or the kind of variable that should be uh, that actually comes into the picture, such as trust, satisfaction, financial literacy, behavioral biases, or investment decision. Structural equation modeling is used. SEM has two major approaches: PLS-SEM, CB-SEM. PLS stands for partial least square, and CB-SEM stands for covariance-based structure. So these are basically used for different conditions that we'll be discussing as the video goes along. What is SEM? SEM is structure equation modeling. Is a statistical technique that combines what? Factor analysis, multiple regression, path analysis. As I told you, if it is simple median mode, if it is simple descriptive and statistics, then we go for Excel, or if little bit of complex there is, then we go for SPSS. But if things are more complex, there are more variables involved, there are intervening variables involved, which includes mediating, moderating, then we go for SEM, and we'll be deciding now whether to go for CB-SEM or PLSM. Okay. It allows researcher to examine relationship between observed and latent variable. Observed variable, those who are observed, and latent variable. For example, here investment decision is being observed. This is being tested to find its impact on this, and this comes mediation. So this is not simple IVDV. There is mediation involved. There must be different types of indicators involved. So that is why we used SAM. Okay. Now, what is CB-SEM? Stands for covariance based structure equation modeling. As I told earlier, the main objective is to determine whether proposed theoretical model fits the observed data. It means there is theory that has been previously published. Now, what we have to see is whether our collected data fits that theory or not. It's just like confirmatory. There was a video that I made on confirmatory factor analysis, where we confirm that our I that the items we have taken from previous studies, whether we confirm whether they apply to our current study or not. So it's not exploring, it's confirming. In simple word, it is my theory correct? So these are characteristics of CB-SEM, and in some way I would say there are some limitation. Let me tell you why. Theory testing, okay. Theory confirmation, yeah. Model fit is most important, okay. We see whether the model fit our collected data or not. Requires large sample. Now here it is characteristics as well as limitation. For example, we have data of 100, we have data of 150, we have data of 200. So it is little impossible, and not we are not able to analyze data through CB-SEM because it requires large data. On the contrary, if we see PLS-SEM, it is suitable for small as well as large data. Requires normal distribution of data, which in on the other hand, PLSM does not require, and is sensitive to outliers. Outliers means those values that are little off uh, when it comes to average. Okay. Theory. Now theory is trust, customer satisfaction, loyalty. In previous studies, If previous studies already support this theory, CB-SEM check whether your collected data also supports the same theory or not. Yeah, now comes the second SEM, that is PLS SEM, into the picture. PLS SEM stands for partial least square structural equation modeling. Its objective is prediction and explaining variation. It's not just there's previous published theory and we have to confirm whether this applies to a respondent or not. It predicts and explain variation variance. Instead of asking, does my model fit, which we do in case of CB-SEM, it asks, how well can my model predict? How well can my model predict the actual situation? Okay. Characteristics of PLSM. Now, this is just for the sake of, interview, or you should know what PLSM actually mean. But when to use, that crux is going in the furtherance of this video. Characteristics of PLSM: prediction oriented, exploratory research. It does not confirm, it explores how well my research, my participants fits to the previous um, theory that suitable for new theories. Oh, sorry, that is suitable for new theories. How well new theories can be applied. Works with small sample sizes, as I told you. Does not require normal distribution. It does not require normal distribution. So obviously its area of data analysis become very vast. Handles complex model efficiently. Okay. Suppose you're studying behavior bias, that is your IV, risk perception, that is your risk mediating variable, investment decision, that is your um, dependent variable, and second investment decision, that is your dependent variable. So it could be serial mediation, or you can just consider this as your model. And the moderator life, financial literacy, digital literacy. So this must be financial literacy must be impacting this, digital literacy must be impacting this. PLSM is generally preferred because the model becomes more complex. It's not simple descriptive statistics and inferential statistics for that matter. It's more complex than even inferential statistics. Okay. Okay. Major difference: CBSM focuses on theory confirmation. PLSM focuses on prediction and theory development. Means, for example, in exploratory, there are items that we generate, but in confirmatory there are items that we confirm. So here is also the same thing. CBSM focuses on theory confirmation. There is previously generated theory, we have to confirm it. But PLSM focuses on prediction, how well my respondents respond to this particular theory, and theory develop, they develop theory. Now coming on to the main crux, why, when we have a model, when we have for example reflective versus formative model. Reflective basically are those model or those variable when you have a construct, and then variables come out, items come out of them. For example, overconfidence bias. There are four ways to measure overconfidence bias. For example, these are four, but these are highly correlated to each other. That is reflective. But if I talk of formative model, there first there will be indicators, then these indicators together will form what? Variable or construct. So here first you have construct, then you have indicators. But here first you have indicators, and these indicators collectively form what? Construct or variable for that matter. So the construct cause indicator, construct causes indicator. We have construct and we find different ways in which it can be explained or it can be answered by our respondents. That is construct, then items or indicators. We call them same. It's about the area. Then here we have items or indicator, and they collectively, if one of them will remove, they will not explain the particular variable. For example, this social economic status, there will be income, there will be education, there will be the class they belongs to. These three together become the deciding point for social economic status. If one of them we remove, the other two will not explain. But in this case construct, This consists of four things. These are four these four items or indicator correlate with each other, and even if you remove one of them, it will not matter a lot. Okay. So in this case of reflective, so basically PLSM is you know fits for reflective as well as formative. But in a case if we have to go for if there is just formative model, then we will go with CB-SEM. Okay, no, no, no. This becomes, sorry, that's my mistake. If there is formative model, then only PLS-SEM, because it becomes complex. In case of reflective, we can use CB-SEM as well as PLS-SEM. Okay, so relationship construct. First we form construct, then indicator, and formative model. First there are indicators that collectively explain the construct. Cause latent variable causes the indicator. There are variables that causes indicator or items. Indicator form the latent variable. There are items that together form the variable. Indicator usually highly correlated. The items that are formed from construct, these are highly correlated, may or may not be correlated. Removing an indicator usually does not change the meaning of the construct. For example, these are construct, there are different items. If we want remove one item, these two will also explain this, and it will not matter with the construct. Can change the meaning of the construct. If we remove one or two item, it will definitely change the meaning of the construct. Reliability, Cronbach alpha and composite reliability, average variance extracted. These are under reliability test, not appropriate. Accesses collinearity and indicator weights the significance. This is basically more technical term which will be discussing in the furtherance of this series. Okay, commonly used in psychology, marketing, behavioral finance, and index development composite. So I got confused whether formative we use CB-SEM, but keep it in mind only PLSM will be used when the model is formative. But if there is reflective, then PLSM and CBSM both can be used. Okay. Now finally we come to a conclusion whether to use PLSM, when to use, whether to use CBSM. PLSM is preferred for formative constructs. I told you PLSM is preferred for formative model or formative constructs, because formative indicator create the latent variable. Formative indicator together create the latent variable and are not required to be highly correlated. These are not highly correlated. That's why we used PLSM. PLSM directly estimates indicator weights, evaluate multicollinearity and significance through bootstrapping. Now, bootstrapping is basically resampling, which we'll be studying in the furtherance of this series. Multicollinearity means that collinearity is multiple, and this is also technical term we'll be discussing further. CB-SEM was primarily developed for reflective measurements and theory confirmation. So modeling formative construct is more complex than straightforward. So when formative construct are involved, it becomes more complex and less straightforward, and we use PLS SEM. But CB-SEM primarily developed for reflective measurements where we have construct and then we form indicator, which are highly correlated among each other, and theory confirmation. There is previously generated theory and we confirm whether that theory particularly applies to this particular data of respondents or not. So that's it for today. I hope you liked it. If you did, subscribe to the Scholars Guide, and I, my friend, we'll see you in the next video, and please comment down your valuable suggestion. Okay then, bye bye.